At this point, we have enough elements to create a passivation validation package. The validation package should be unambiguous and clear. There should be no room for questions about what was passivated, the location, when and who was involved. If those questions are not fully answered, or indeed there is a doubt or fuzziness with the one interpretation, the validation package is incomplete. Some examples of the document's details for proper identification are the document's version, approvals, and company's name.
Include an objective in the document. You can see the complete wording in the presentation, but it essentially says, it is a description of the passivation procedure to meet a regulatory agency requirements. To say that we passivate a water loop or a pump is not clear enough. For example, does the water loop include the pipe between the generation train and the water loop? Or what is the serial number of the passivated pump? Drawings help us to identify better what we clean. For example, pipe and instrument drawings or P&IDs, part drawings, well maps, or any other suitable drawing.
In this image, we see a highlight P&ID. In a P&ID, we can show flow paths, what components were removed, isolated, the valve positions, injection and returning points, and some other pieces of information when we passivate by recirculation. Here we can see a P&ID of a portable cleaning in place system used for passivation. This drawing is a part of the equipment's description used to recirculate, heat, filtrate, mix chemicals, and measure the flow. A procedure is not a checklist, neither a job safety analysis. Frequently, I have seen these documents as procedures. They can be part of the procedure, but are not enough by themselves. Do not accept a generic checklist that says, for example, 1. Inject the chemicals, 2. Recirculate the chemicals, and 3. Customs to verify the process. No, a procedure should be very detailed. In recent years, environment, health, and safety have become more critical. Some of the documents that address EH&S are risk assessments, MSDS, and waste disposal. Some calculations and engineering considerations are essential for the process, such as liquid volume, so document those. It is necessary to define responsibilities like who will provide the water for the process, who will perform the quality control, or who will provide the services required to execute the procedure. Those should be defined also in the validation package. A revision in advance of the procedure will allow you to avoid interferences with other operations and adapt it to your circumstances. Explain the sampling rationale. If we are going to perform chemical testing on the surface in contact with a product, we need to document that the chemicals for testing were removed. Coupons must represent the worst-case scenario, like welds for new installation for metal with corrosion in all structures. Rinse samples or chemical samples represent all the areas in contact with, and are the best technique for equipment that cannot be disassembled easily. If we use rinse samples, make sure they are representative and not taken from a dead leg, and the sampling port is flushed previous to take the sample. Higher the quality of the water, the higher the level of cleanliness that we can achieve. We can say that conductivity must be under 2 microsiemens per centimeter, or use purified water or water-free injection as per pharmacopoeia. Inspect the temporary equipment to be used for passivation. Does it look clean? Is it in good condition? Is it devoted to clean facilities? take advantage that the equipment to be cleaned is shut down and inspect its condition. Is there any visible debris? Is there corrosion or scale? Include the batch number and certificates of analysis of the chemicals. The calibration of critical instruments must be certified and documented. Define the acceptance criteria. During cleaning, some chemical reactions happen. Concentration, time, and temperature will affect the chemical reaction. However, the usual conditions are much more than those required. This time I will use chemical sanitization as an example. Let's suppose that there is a biofilm inside a pipe. Consider a sanitization recirculating a hydrogen peroxide solution. We probably need some milligrams or grams of hydrogen peroxide to kill the few bacteria, depending on the solution's volume, but very likely we will use some kilograms of hydrogen peroxide. We need a 0.5% solution of hydrogen peroxide at 20 degrees Celsius for 1 minute to kill a bacteria. Although our conditions are 3% solution at the same temperature for 30 minutes. There is no difference in these conditions if the solution is 2.9 or 3.1% or if we recirculate for only 28 minutes or 40. On the other hand, the testing method sensitivity is critical to proving that we remove the biofilm. Now that we have understood that some latitude is acceptable in some parameters, let's see the critical points in passivation by recirculation. Chemical concentration. Keep in mind that cleaning is more like a kitchen recipe than a chemical analysis. We don't need high precision when we are preparing the cleaning solutions. Chemical removal. We can choose a specific method to measure a compound or use a quantitative indicator like conductivity or total organic carbon, or TOC. Any passivation test identifies free iron removal. Other impurities need specific methods to confirm that have been removed. Contact time. We don't need a chronometer. An error of a couple of minutes is acceptable. pH. Using indicator strips with an accuracy of plus, minus 1 pH unit is enough. Temperature. For liquid solutions, the higher the temperature, faster the cleaning. However, pumps can cavitate when we are getting close to the boiling point. Mechanical forces. Turbulence and impact forces can improve the cleaning process. These parameters are critical when there are particles that we want to remove. In those cases, we may need to use a flow meter or a jet nozzle following the manufacturer's recommendations. From time to time, I have seen some misunderstanding about pH as evidence of removing chemicals. Hydroxides and acids that we use for cleaning and passivation have an extreme pH. However, it's possible to have a neutral solution with many chemicals on it. Also, keep in mind that purified water by itself can have a pH between 5 and 7. Some fast methods to measure residues are conductivity, and if we use organic compounds for cleaning, TOC. An MSDS is not the same as a quality certificate. A quality certificate allows us to trace the chemicals with lot numbers. Additionally, a quality certificate or certificate of analysis provides a detailed report of impurities in a substance. Here we can see a portable conductivity meter and its calibration certificate. Conductivity is critical to prove the removal of the residues. The word passivation can be confusing. In the pharmaceutical industry, passivation is cleaning stainless steel with an acid, removing iron and creating a chromium oxide corrosion-resistant layer. The passivation process requires an alkaline cleaning first. Sometimes the passivation process also includes an oxidation stage that sanitizes at the same time. This picture shows tubing with corrosion and each of the possible stages of a chemical cleaning process. The pressure testing can be with water or gas. The test will help us to identify leaks and confirm the equipment integrity and reliability. During the water flushing, we can remove particles, and we can also heat the water. The alkaline cleaning can remove organic matter, biofilms, and other impurities soluble at high pH. In passivation, we eliminate the free iron and create a non-reactive surface. If the corrosion is generalized before passivation, we will need pickling. Pickling is the removal of oxides with acids. In the case of water loops and cleansing systems, we call it derugging. If there is microbiological contamination, we can do a chemical sanitization or disinfection. Once we remove all the chemicals and pass the acceptance criteria, we will have clean metal. Thank you for your interest in my presentation. If you have questions or comments, please send me an email.